Hello everyone, we're back with another paper today after a long break. Today we're solving this physics paper 1 multiple choice question paper from February March 2024. It's paper 1 2, the time is 1 hour 15 minutes. I actually got a new microphone, so my voice might seem a bit different. So my plan is to release videos weekly now, hopefully more consistently. And our next targets will be to solve all the papers from the 2024 and 2023 series for physics, chemistry, math, and biology. I'll be uploading more bio content soon, as well as more math, P1, P3, M1, and S1. So subscribe to the channel if you don't want to miss anything. Before we start the video and talk about the threshold, a quick shout out to my Patreon. If you guys want access to all of these solved papers that I have in the past, like 2017, 18, 19, etc., from 2016 to 2024, mostly all of them are solved. If you want access to all of these, please do consider supporting me on Patreon. It's patreon.com/CAIE papers solved. I'll give a link in the description. So currently we have 3 tiers. The first tier is just for general support. The highlighted tier is the most common one. We currently have 7 members here. You get access to one-on-one problem solving sessions over text message on Patreon or Discord, wherever you prefer. Then you have access to the solved question papers from 2002 to 2023 with working in OneNote for all my subjects. And you get notes for AS and A2 physics and chemistry. And you get access to ad-free videos as well. Like all the videos that are available on YouTube are available on Patreon ad-free. Basically YouTube Premium is included in the subscription, essentially. But yeah, all questions aren't solved from 2002 to 2023 because the syllabus was much different before 2009. So mainly 2016 to 2024 is completely solved, but before that it's like scarcely distributed, but there are still solved papers, okay? And for the ultimate learning experience, you actually get one-on-one video meetings with me via Google Meet once a month typically, sometimes twice a month. And you get access to all the previous benefits. So you can consider supporting me on this tier near the end of your exams, where we can talk about your personal problems and it might help boost your grade. Okay, so I think we should talk about the threshold now. Okay, so take a look at this. For paper 1 2, A was at 32, B 29, C 25, D at 21, and E at 18. Wait, sorry. Here we go. So let's write it down. So the threshold, out of the maximum available raw mark of 40, we had A at 32, and then B at 29, C at 25, D at 21, and an E at 18. So as you can see, the mark distribution is like 4 to 3 marks. So A star should be at around 35 or 36 for this particular paper. It's not given in the threshold, but it's hidden because the A star actually comes after averaging both AS and A2. So afterwards, that's why, basically. Okay. So I think we should begin without any delay. Data booklet. Also, I'll link the paper. I'll give a link for the paper down below in the description, along with timestamps. Okay, a lot of you have been requesting those, and please, if you do like my content, if you like supporting me, please do consider subscribing to the channel, because there are a lot of viewers who don't subscribe but just watch. Subscribing would mean a lot, and it helps with the algorithm a lot, basically. Okay, so let's start. Which row shows a physical quantity and its base unit in the SI system? Okay, so we have 7 base quantities and all the others are derived. So let's look into this. Current is a quantity that is correct, and ampere is its unit, so A is our answer. But force, on the other hand, it is a quantity, but Newton is not a base unit. It's a derived unit. Mass, the base unit was supposed to be kg, okay? And for temperature, it was supposed to be Kelvin, okay? That's why these are wrong. Although these are base units, base quantities, I mean. Number 2, a car of mass 850 kg is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. One force has magnitude 1200 and the other force has magnitude 1600. What is the magnitude of the acceleration? So we know that F is equal to ma, so we need to find out the resultant force. So that is 1200 minus 1600 is equal to ma, 850 into a. I'm gonna find out the answer. Minus 400 by 850. So the acceleration is actually minus 0.47 because we are decelerating, okay? It should be minus 0.47, but since they said magnitude, the sign doesn't really matter. Now, number 3, an object of mass m is suspended by a spring from a fixed point. The spring has spring constant k. The object is set into vertical oscillations of period t, which equation for t is homogeneous with respect to base units. So we are looking for seconds. Okay, so 2 pi has no unit. Then k is actually the spring constant. So we know that F is equal to kx, k is equal to F by x. So the unit of k will be Newton per meter. And what is this m? Mass m, right? Mass m. So yeah, mass m. Mass m 1 by kg. So let's do this. 2 pi has no units, so we ignore that. Newton is kg ms minus 2 because F is equal to ma. So kg times meter per second square times 1 divided by kg, and there's a mass down below. So we can get rid of the mass. We can also get rid of the kg, but we actually end up with second to the power minus 2, which is why A is not our answer. I will give you a hint, guys. I always tell this to all my students. For trial and error questions, typically the answer tends to be D. So we should try doing D. So it's 2 pi times root over mass is kg, and this was second to the power minus 2, which is wrong. So we clearly need a root over to get rid of the 2. We need to convert to 1. And we also need a reciprocal of this k by m. So I think D should be the right answer. K is F by x, which is kg ms minus 2 divided by k is F by x divided by meters. Okay, so we can get rid of the meter, we can get rid of the kg, and we end up with t is equal to 2 pi no unit into root over, after you reciprocal this, it's actually s square, so the unit is root over s square, which is s. So we have our answer. The correct answer is in fact D. So guys, a lot of you have been asking why haven't I released this paper yet. I actually didn't get access to the mark scheme before and the question paper as well. So I sadly couldn't upload it before the paper 1 exam, the May June 2024 paper 1 exam, sadly. And I've seen a lot of YouTubers solve it without the mark scheme, which is wrong, because you shouldn't do that, okay? Because that leads to more mistakes, basically. So it's something that you should avoid, solving a question paper without the mark scheme. Now, an object of fixed mass is initially at rest at point P. The object then moves away from point P with uniform acceleration, which statement describes the resultant force acting on the object when it is moving. So let's think about this. An object of fixed mass is initially at rest. Fine, that's the key point. It is initially at rest. The object then moves away from point P with uniform acceleration. So we know that F is equal to ma. Mass is constant, and this acceleration is also constant. So if this is constant and this is also constant, what will happen to the value of force? Think about what will happen to the value of force. The value also has to be constant. Okay, so we are looking for a constant value. So it increases is wrong. It is constant, okay, but not 0. That is correct, because we do have a mass and we do have an acceleration, so the value can't be 0. Number 5, a projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of velocity 13 meter per second. What is the vertical component? Okay, so a projectile is launched with an angle of 25 degrees and the horizontal component actually happens to be 13, and this is v. So two ways to do this. We can either find v first. We know that v cos 25 is equal to 13. So v is actually equal to, well, let me do it. I need to change it to degrees. 13 by cos 25, which is 14.34. Then we are supposed to find the vertical component, v sine 25. So answer into sine 25 is 6.06. 6.06, which is b. The other way was just using trigonometry. You know that this is a 90-degree right angle triangle. So you could just find this v out directly. How? You could go for, you know that this is 13, right? So tan 25 is equal to opposite by adjacent. So 13 times tan 25 would also give you v is equal to 6.1. That is another way. Two ways to solve this sum. Okay, so 5 is in fact b. Next, number 6, a ball is released from rest at position x at time 0. At 1 second, it bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce at 1.5 seconds. What is the total displacement of the ball from its original position at 1.5 seconds? Okay, so it's like this. The ball is released from position x. It falls down, hits the ground at time 1.0 seconds, and then goes up again and reaches a certain height. So this distance, the first one that I've shaded, is this distance over here, the one it travels downwards. And the orange triangle that I'm shading is actually this distance. So to find out the displacement from the initial position, what I need to do is I need to subtract, to find out the purple one, I need to subtract the orange one from the pink one, basically. Okay, so this displacement will actually be the first distance, which is half into 1 into 10, the bigger triangle, minus half into 0.5 into 5. I should get the answer then. 0.5 into 1 into 10 minus 0.5 into 0.5 into 5. That gives me an answer of 3.75 meters. Okay, so I'm getting an answer of 6b. What is the definition of acceleration? Okay, so basically what we have to understand here is two definitions are really important. Force is the rate of change of momentum, and acceleration is the rate of change of velocity. So a is equal to v by t, del v by del t, rate of change of velocity or change in velocity per unit time. So why is c wrong? Rate of change of velocity already means this, and if you say per unit time, that means you're adding another time down here, which is why it's wrong. So you either define acceleration as the change in velocity per unit time or the rate of change of velocity, but that's it. Number 8, two balls P and Q of equal mass move along a straight line directly towards each other as shown. Ball P has velocity 1.30 meters per second to the right, and ball Q has velocity 0.5 meter per second to the left. P and Q collide with one another. The collision is perfectly elastic and the total momentum is conserved. Okay, so since it's elastic, the relative speed of approach will be equal to the relative speed of separation. So what is the relative speed of approach in this question? If they travel towards each other or away from each other, then you add up the velocity. So the relative speed of approach is equal to 1.30 plus 0.50, which is 1.80. yeah, 1.80. So the relative speed of separation, must also be 1.80. So check this, they're traveling in the same direction, so it will be subtraction. So 0.58 minus 0.22, 0.58 minus 0.22 is 0.36, wrong. Then same direction, 0.4 minus 0.4 is 0, no relative speed. And then C, opposite direction, 0.99 plus 0.19, how much is it? 0.99 plus 0.19 is 1.18, and this one 1.30 plus 0.5, which is 1.80. Perfect. See, I told you, trial and error answers tend to be D. Okay, so the answer for 8 is D. Number 9. A basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.9 meters. Air resistance is negligible. What is the speed of the ball as it hits the ground? Hits a ball vertically downwards with a speed of 2.4 and a height of 0.9, no air resistance, so just acceleration of free fall. So v square is equal to u square plus 2s. V square is equal to 2.4 square plus 2.4 square plus 2 into 9.81 times 0.9. Okay, 2 into 9.81 times 0.9 plus 2.4 square root over answer. I'm getting an answer of 4.84. Yeah, 4.84. So 9 is B. A ball falls through a liquid at a constant speed. It is acted upon by three forces: upthrust, a drag force, and its weight. It has uniform density. Which statement is correct? The drag force increases with increasing depth. Not necessarily. Drag force is like air resistance. It actually increases with increasing velocity. But actually, it is at constant speed. So the drag force remains constant. Okay, so this is wrong. Next, the drag force is equal to the sum of the upthrust and weight. No, look, weight is downwards, upthrust is upwards, and since it's going down, falls, it is going down, right? So the drag is also upwards. So it's constant speed, so drag plus upthrust is equal to weight. This should be the equation. Drag plus upthrust is weight. See, the upthrust is constant with increasing depth. The formula for upthrust is, formula for upthrust using Archimedes principle is V rho g. V rho g. The volume of the ball. This is the volume of the ball of the object. Rho is the density of the liquid, and g is acceleration of free fall. Since these three quantities do not change, that is why answer C is correct. Okay. And no, D is wrong because weight is not greater than the sum. It is actually equal since it's moving at constant speed. Okay. We are at 11. Some small solid cubes each have mass 1 kg and size of length 5 centimeter. These small cubes are stacked together to form a large solid cube with sides of length 2 meters. What is the weight of the large cube? Okay. I need to understand this question. Some small solid cubes each have mass 1 kg and size of length 5 cm. Okay, so we have some small cubes like these, length 5 cm and mass 1 kg. Now these small cubes are stacked together to form a large solid cube with length 2 meters. So we have a large cube now, like these, like this actually, but it is composed of many small cubes. What is the weight of the large cube? So for this side to be 2 meters, which is 200 centimeters, how many small cubes do we need? It's 2 meters. So 200 by 5. 200 by 5, which you need 40 cubes on one side like this. Okay, all right. I think we should do this with volume instead, because we need to consider this dimension as well. So the volume of one small cube is actually 5 cube, 5 into 5 into 5, which is a 125, and the volume of this large cube will actually be length 2 meters, right? So 200 cube. Why don't I do something? I'll keep this as meters. 2 cube, which is 8 meter cube, and the volume of a small cube, I'll keep it in centimeter. The length is 5 by 100, which is 0.05 meters. A cube, which is 1.25 into 10 power minus 4. Okay, so how many do we need? Number 8 divided by 1.25 into 10 power minus 4 is equal to, we're getting 64,000 cubes are required to fill up that volume. Okay, 64,000. Now basically each cube has a mass of 1 kg. So if I multiply this by 1 kg, we are actually getting the mass, which is 64,000 kg. And to get the weight, we have to do mg. So this into 64,000 into 9.81 into 9.81, that gives me an answer of 6.28 into 10 to the power 1, 2, 3, 4, 5, 10 to the power 5, or 0.63 into 10 to the power 6 Newton, or 0.63 meganewtons, which is why my answer is C. 11 is C. Okay, interesting and new question. I haven't seen this before, first time. Okay, number 12, a borehole of depth 2000. The bottom of the borehole is 17.5 megapascal. The density of the oil is 830 kilogram per meter cube, and the density of the water is 1000 kilogram per meter cube. What is the depth though? Okay, so the pressure will be a combination of both of them. So we can write 17.5 times 10 to the power 6 is actually equal to x by 2000. Should be h rho g, right? H rho g. X into density of oil, h rho g, rho into g, 9.81. This plus density of water, and its height will be 2000 minus x times rho 1000 times g, 9.81. Okay, we are good to go. So 17.5 times 10 power 6 is equal to 8142.3x plus 2000 into 1000 into 9.81, which is 1.962. 1, 2, 3, 4, 5, 6, 7 into 10 power 7 minus 1000 into 9.81, 9810x. Okay, so yeah, let's do this, I guess. So 17.5 into 10 power 6 minus 1.962 into 10 power 7 is equal to 8142.3. 8142.3 minus 9810, that is minus 1667.1. 17.5 into 10 power 6 minus 1.962 into 10 to the power 7, that gives us an answer of minus 2120000 is equal to minus 1667.1x. So if I divide this by minus 1667.1, I actually get x is equal to 1271.67. So the closest answer to this after rounding off is D, 1270 to 3SF. Perfect. Next, number 13. A rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0. The weight of the rod causes a moment about the pivot. The rod is then rotated in a vertical plane, so the angle of the rod increases from 0 to 180, which shows the variation of m with theta. So what do we have? We have a rod at one end, and it is pivoted at one end. Initially, the angle theta of the rod to the horizontal, is 0 degrees. Now the weight of the rod, the weight will act through the center like this. The weight of the rod causes a moment m. So initially, the weight is perpendicular to the pivot, because we know that the rod is horizontal. So initially the moment should be maximum. Okay, initially the moment is m. Now it is rotated in a vertical plane. It is rotated in a vertical plane so that the angle increases from 0 to 180. So it will change from 0 to 180. So over time, what will happen? The rod will assume this position next. Like the pivot will still be here, but the rod comes like this because the angle to the horizontal, now look, initially the angle was 0 degree, but now the angle to the horizontal has become 90 degrees, and the weight is acting vertically downward still. Now the weight is passing through the pivot, and we know that if any force passes through the pivot, then there is no moment about that point if the for that particular force. So at 90 degrees, since the weight passes through the pivot, logically speaking, at 90 degrees the moment should be 0, which is why A is wrong. It is between B, C and D, because at 90 degrees the moment is 0. Okay. Now what? How do we find out the correct answer? Again, if you look at it, at the last stage, what will happen when this happens? When we rotate it about 180 degrees completely, now it's like this, and the weight is still acting through the center. There is still a moment, but in the opposite direction now. Okay, which is why B is wrong, because the initial moment was, maybe it was clockwise, but now the moment through the about the pivot is actually anti-clockwise, so it has to be negative. Okay, so initially it's positive, but later it's negative, so it's between C and D actually. But the thing is, if you think about it this way, will it be linear or curved? The answer is curved. I'll tell you why. Because if it was at, maybe like this, if it was like this, at maybe, at maybe 45 degrees to the horizontal, okay? Maybe this was 45 degrees. So think about it this way. This is the weight. We had to take this particular distance, this one, right? Now, the logic is this relation. Let me draw it again, wait. Suppose if it's like this, and this is 45 degrees, and the weight is acting through this one, and we need this distance, right? This particular distance. So how would we find it out exactly? We need to use a trigonometric ratio like sine or cos, which is why it's not a linear relationship but rather curved. That is why 13 is in fact D. Okay, so take a look at this. I think we should move on to 14 then. Let's move on. A hinge trap door is held closed. It's held closed in the horizontal position by a cable. Three forces act on the trapdoor: the weight, the tension, and the force H at the hinge. What is the increasing order of the forces in ascending order? So hear me out, okay? Basically, H has a downward component and a horizontal component, and this T has a vertical component and a component towards the left. The logic is T will have the highest value. Why? I'll tell you. Because T by itself has to balance the downward force of W as well as the downward force of H. It has to do most of the heavy lifting because it has to balance out two downward forces, which is why T should have the highest magnitude, and that is why the answer is C. In any other one, we don't see T at the end. What is the definition of force? I already told you guys. It is the rate of change of momentum according to Newton's second law. 16. A boat moves at a constant velocity through still water. A constant drag force is acting on the boat. What is the power used by the boat? Okay, so we know that P is equal to FV. So it's moving at constant velocity. So the drag force will be equal to the driving force F. So the power will be F times V. Literally, that's it. F times V. I just used the formula. The diagram shows four forces acting on a circular disc. Each force has magnitude F. Two of the forces act vertically and the other two forces act horizontally. All four forces act in the same plane. No other forces act on the disc. The disc has diameter D. Which statement is correct? So the forces cancelled out. Upward force equals to downward force. Right force towards the right equals to force towards the left. And the clockwise moment will be equal. Not really. All of them are actually providing, look, all of them are providing clockwise moment. So although the net force cancels out, it is not equilibrium because there is resultant torque. So our answer should be like this. The disk is not in equilibrium because it has a resultant torque. So it should be not in equilibrium. It is not in equilibrium because the resultant force is 0, but there is a resultant torque. Okay, because this distance is d, fd plus fd, it's 2fd net torque, net moment. Next, 18, a ball is projected into the air from horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the ball has kinetic energies E, Q, E, R, E, S, and E, T respectively. The heights above the ground of these 4 points are shown. Which difference in kinetic energy is the smallest? Okay. So, at this point, okay, kinetic energy is the least. And kinetic energy has no, how should I say this? Kinetic energy does not have any sign. So even if the velocities have different magnitudes, the magnitude only matters here. Okay, the magnitude only matters. So we are looking for the least difference. Like if we compare these, what is the difference? It's 0.3 meters. If we compare this, it's 0.2 meters. If we compare this, it's 0.3 meters again. And there's no point comparing 1.8 to 1.3. It's 0.5 meters. And if you compare 1.5 and 1.6, look, this one, the side really doesn't matter. Okay, it's 0.1 meters. So S and Q, that should be the answer because the difference in height is the least. And although the velocities have different signs, one is positive, one is negative, the vertical component obviously, but the difference in magnitudes will be the least. That's the logic, how to do this the fastest. 19. The battery of a small tablet computer is initially uncharged. It is connected to a constant 10 watt power supply for 2 hours to charge the battery. The efficiency of the charging process is 80%. What is the total energy stored in the battery? Okay, so we know that energy is equal to VIT or P into T. So that is 10 into 2 hours, 2 into 3600. But 80% of it will be stored, so times 80%. So 10 times 2 times 3600 times 0.8. That should be 57600. 57600. I'm looking for this. So that is actually 5.8 into 10 power 4, which is C. Perfect. D, an initially stationary firework explodes and splits into 2 fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E. One fragment has mass m and the other one has mass 2m. What is the speed of the fragment of mass m immediately after the explosion? Okay. Momentum has to be conserved, yeah. So half, or let's do it this way. So one fragment to mass m and the fragment of 2m. So this one will have a velocity of 2v, and this one will have a velocity of v. Okay. The total kinetic energy of the two fragments is E. So we can write it like this: half into m into 2v square plus a half into 2m into v square is equal to E. This is what we get. After simplification, 2mv square plus mv square is equal to E. So capital E is actually equal to 3mv square. Do you guys get it? This is the small fragment and this is the larger fragment. So we want the speed of this little guy over here. So in terms of E, of course. So I'm going to find out V first. V is equal to E by 3m root over answer. But since the smaller fragment has a velocity of 2v, this should be doubled. Okay, this should be doubled. I think I made a small mistake somewhere. Wait, let me check. Initially stationary firework splits into two fragments. Total kinetic energy transferred is E. One fragment has mass m and the other has mass 2m. So this is 2m into v, this is m into 2v, okay? Half into m into 2v square. Okay, 4 by 2. So that's 2mv square, and this is half into 2m into v square is equal to E. Let's see. Why isn't it working? The velocity of the small fragment is 2v, so it should be 2 times of this. I think, no, we did it right. I was just confused with one small thing. Okay, so this is v. Now the velocity of the small fragment is actually 2 times root over E by 3m. Now look, what can this be written as? 2 can be written as root 4 times root over E by 3m. Do you get it? That's why I wasn't understanding actually. So that is actually equal to root over 4e by 3m. So the answer is actually D. Because look, it's 2 times this. If you root over this, you actually end up with 2 root over E by 3m, which is this answer over here. So tricky in that sense that the answer was not in front of our eyes. We had to figure it out. Now 21. What do we have? A spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law. Which relationship is correct? Okay, so we know that elastic potential energy is equal to half Kx or half Fx, right? Half Kx square or half Fx. That is what we know. That is elastic potential energy. So this is a constant, so we can say that EP is proportional to x square. Since they told us to use K, so like that basically. Now it says that it obeys Hooke's law. That means it is still proportional. So logically the answer should be D. You might be wondering, you might think that, EP is also equal to half Fx. So why can't I say that it's proportional to F or proportional to X? Because look, For you to get a relationship, all other things must be kept constant. For example, if I used EP is equal to half fx, I can't say that EP is proportional to f. Half is a constant, but x is not a constant, it's a variable. Do you guys get it? So the only equation that we can use is this one on the left. EP is equal to half kx square, where half k is a constant and the only variable is x square on the right hand side. Does that make sense? Which is why 21 is in fact D. Okay? That's the logic. 22, a force extension graph is produced for a middle wire. Force extension graph. Limit of proportionality. There are two things: limit of proportionality and elastic limit. Limit of proportionality actually refers to the point till Hooke's law is obeyed. After that, it does not obey Hooke's law. And the elastic limit is like after that point. So this is the limit of proportionality and this is the elastic limit. After you go beyond this point, the wire will not return to its original length. So, and D is the same thing, the point beyond which the wire starts to deform plastically. C and D refer to the elastic limit and B refers to the limit of proportionality. 2. A spring has a spring constant of 6 Newton per centimeter. It is joined to another spring whose spring constant is 4. A load of 80 is suspended. What is the extension? Okay, so this 80 will apply to this one as well as this. So we know that F is equal to kx. Okay, so x is equal to 80 by 6 and x is also equal to 80 by 4. So 80 by 6 is actually 13.33 and 80 by 4 is actually 20, and these are centimeters, by the way. So in total we have 33.33 cm. So logically speaking, 23 is D. 24. The range of frequencies of sound waves emitted by blue whales is 10 to 40 Hz. The speed of sound in seawater is approximately 1.5. What is the approximate range of wavelengths? Okay, we know that V is equal to F lambda. So it's in, oh, okay, I'll convert it to meter. 1500 meters per second, the SI unit, is equal to 10 times lambda. So 1500 by 10, which is 150 meter. And on the other hand, 1500 is equal to 40 times lambda. So 1500 by 40 is 37.5 meters. Okay, so this is the range in meters from 38 to 150 meters basically in SI units. 25. A sound wave is detected by a microphone and displayed on the screen of a cathode ray oscilloscope CRO. What is the time setting of the base, time base? Okay, so 4 boxes, frequency 2.4. We know that time period equals to 1 by f, time period equals to 1 by 2500. So 1 by 2500 is 4 into 10 to the power minus 4 seconds. So 4 boxes is this. So 4 boxes. I'll convert this to millisecond, yeah? Let's convert to millisecond into 10 to the power 3. So time period is 0.4 millisecond. So 4 boxes is 0.4 millisecond. So 1 box will actually be 0.4 by 4, which is 0.1 millisecond. Each box is 0.1 millisecond per box or per centimeter. Per box is 1 cm. So it's 0.1 millisecond per box. 25 is A. 26. A source of sound waves with constant frequency moves towards a stationary observer. The observer compares the sound waves arriving at the observer's position with the waves emitted by the source of sound. What is detected by the observer? So since the source is moving towards the observer, Doppler effect will occur and the frequency will increase and the wavelength will decrease. So it will be an increase in frequency but a decrease in wavelength. So the answer is actually C. Only C matches. which type of waves cannot be polarized? So polarization of waves is, it actually only applies to transverse waves. So since sound is longitudinal, it cannot be polarized. All the others are what? Electromagnetic waves, which are all transverse waves. 28. A beam of light with power P has an area of cross section A. The amplitude of the light waves in the beam is x. The beam of light is then changed to one with same frequency but an increased amplitude of 4x, and the area of cross section is reduced to A by 3. Okay. So intensity is equal to power by area. So amplitude is x. It has same frequency, but the amplitude is increased to 4x, and the area of cross section is reduced to A by 3. Okay, what is the new power of the beam? On the other hand, we also know that intensity is proportional to amplitude square, right? Intensity is proportional to amplitude square. So since they want power, power is basically area into intensity, yeah? So initially what we had was power is equal to area into, instead of intensity I am going to apply x square, okay? But now the new power, what will it be equal to? The area is changed to A by 3, but the amplitude is increased to 4x from x. So that is actually 4x whole square. So power is equal to A by 3 times 16x square. That is 16 by 3 ax square. Before it was just ax square. Now it's 16 by 3 ax square. 16 by 3. I think this should be the answer. I'm getting 5.33. So let's check with the mark scheme. Yes, in fact, 28 is B. I'm correct. Two loudspeakers are connected to the same signal generator. The signal generator produces a single frequency. The loudspeakers face each other so that the stationary sound wave is set up in the region between the loudspeakers. A microphone is connected to a cathode ray oscilloscope and positioned between the two loudspeakers. The microphone is moved along a line joining the two loudspeakers. The signal shows 5 maximum amplitudes, so 5 antinodes, and the microphone moves a distance of 2 meters from the position that gives the first maximum to the position that gives the fifth maximum. Okay, so it's kind of like this: antinode, 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 antinode. So the pattern is kind of like this. Okay, so we know that one antinode to one antinode is actually lambda by 2. So then we have that again, lambda by 2, that again lambda by 2, then that again lambda by 2. So this is one wavelength, this is another wavelength. So 2 lambda in total between 5 antinodes, and the distance is 2 meter. So lambda is 2 by 2, which is in fact 1 meter. So 29 should be D. Two wave sources emit coherent waves. Which condition must be correct for coherent waves? Basically coherent waves, okay, they coherent, what does coherence mean? Two waves that have constant phase difference. They can be in phase, they can be out of phase, but they must have constant phase difference. That thing must never change. Last 10 MCQs. A student sets up an experiment to investigate a double slit interference. The student uses light of a single wavelength from a laser to eliminate a double slit so that a pattern of interference fringes is observed on the screen. The student finds that the fringes are very close together. What could the student decrease in order to increase the separation? So this is a double slit experiment, Young's double slit, x equals to lambda d by a. So we want to increase the separation of the fringes, fringe width. So we can either increase lambda, increase distance, or decrease the distance r. So what can we decrease? The only answer is decreasing r, the distance between the double slits, the slit separation, or so we call it. So the only answer, possible answer, is 31C. It's just math. What are the definitions of potential difference and EMF? So potential difference is the work done per unit charge, okay, as it moves from one point in a circuit to another point. And EMF is also the work done per unit charge, but throughout the whole circuit instead. So both of them actually have the same definitions. Where's the combined resistance? Very simple. This part will be 1.2 reciprocal plus 1 by 4.7 reciprocal. So 1 by 1.2 plus 1 by 4.7 reciprocal, that is 0.955. Combined is 0.9559, and then added up with 2.2 plus 2.2, that gives me 3.16. 3.16, yeah. So 3.2 is the answer. 33C. This pair was damn easy, honestly. A resistor dissipates 25 watts of power, and when there's a potential difference of V across, what is the resistance? P is equal to V squared by R, we know. So 25 is equal to 4 squared by R. So 16 by 25 gives us an answer of 0.64 ohms. 34 is B. 35. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. The resistance of the variable resistor is decreased. What happens to the potential difference across the variable resistor and the current in the variable resistor? So let's think of two scenarios, yeah? So suppose that this has an internal resistance of 2 ohms, this has an EMF of 10 volts, and suppose this was 4 and this was also 4. So the combined resistance of this set would have been 2. And what would be the terminal PdV? To find it out, it would be terminal PD would be 2 divided by 4, the total resistance of the circuit, 2 plus 2 from internal resistance. The combined one is 1 by 4 plus 1 by 4 reciprocal, which is 2, and the internal resistance is also 2. So 2 plus 2, below it's 4 times 10. That is actually 5 volts, yeah. Terminal PD is 5 volts. And the loss volts is also 5. And what about the current? It will be 10 by 4, the total resistance, which is 2.5 amperes. This is case 1. Now let's talk about case 2. Okay, I'll actually copy this. Wait up. Sorry. Now let's talk about case 2, shall we? I'll just set the data here for case 1. We good? Okay. Now case 2. This is still 10 volts. This is still 2 ohms. But now this is still 4 ohms, but this has decreased to 2 ohms. So what is the combined resistance? 1 by 4 plus 1 by 2 reciprocal, which is 1.33. So what about V? V will be 1.33 divided by 2 plus 1.33, 3.33 times 10. So it will decrease 1.33 divided by 3.33 into 10, which is 4 volts, 3.99 volts or 4 volts. So V has decreased. It went from 5 to 4, but the total resistance is less now, so the current will be 10 divided by 3.33, 10 divided by 3.333, which is 3 amperes. So current went from 2.5 amps to 3 amps. So current increases, but the terminal PD actually decreases. So I'll just check with the mark scheme. Yes, 35 is B. Okay, that's great. We have reached the end of the paper. 36. A radioactive source produces a beam of alpha particles in a vacuum. Average current is this. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in a time of 3 seconds? So we know that Q is equal to IT. I is equal to Q by T. So we have the current 1.5 times 10 to the power minus 9 is equal to, time is 3 seconds, and Q will be number of alpha particles, and we know that an alpha particle has a charge of 2Q. times 2 into 1.60 into 10 power minus 19, the elementary charge. It's available on top on the data booklet. So let's find out n. 1.5 times 10 to the power minus 9 into 3 divided by 2 into 1.6 into 10 to the power minus 19. Okay. So I'm getting n is equal to 1.4 into 10 to the power 10, yeah? 1.4 into 10 power 10. 36 is C. Great. 37. The charge carries in a metal wire free electrons. Which statement out the charge of each electron is correct? Correct. The magnitude of the charge increases? No, the magnitude of the charge never changes. It is fixed at 1.60 into 10 power minus 19. The magnitude of the charge is 0. No, this is also wrong. They always have a charge. The sign and magnitude of the charge do not depend on the potential difference. Right. This is the elementary charge. It is always fixed. Which flavors of quark have a charge of plus 2 by 3e? Okay. So this is very important. Okay. So we are going to learn about all the quark charges. Okay. All 6. So let's see what they are. Basically, we have up, down, charm, strange, top, bottom. So always remember, up is plus 2 by 3, down is minus 1 by 3, charm is also plus 2 by 3, strange is minus 1 by 3, top is also plus 2 by 3, bottom is minus 1 by 3. So which ones have a charge of plus 2 by 3? The answer is charm, top, up, charm, top. Okay, so charm, yes. Top, yes. So yeah, the answer should logically be A, because strange has a charge of minus 1 by 3, bottom is also minus 1 by 3. Okay. 39. An unstable nucleus of an element decays by emitting an alpha particle or a beta mass particle to become a nucleus of a different element. The nucleus is also unstable and emits an alpha particle or a beta minus particle. Okay. This process continues until an isotope of the original element is produced. What does an isotope mean? Elements with the same proton number but different mass number. Okay. So let's try. Suppose I have this element called X and it has maybe, it's 16.8. So it decays by alpha emission, alpha decay, and we will end up with Y, which will be 12 and 6. Then Y decays again. Now I need to increase the proton number. So it will decay by beta minus emission. Beta minus emission. So the mass number is 0, charge of minus 1. So this is actually 12 and 7. And then it will decay again to form element A by beta minus emission again to form 12 and 8. So we got an isotope of oxygen again. 12, 8. So you could do the beta minus emission first, okay? But it mainly has to be 2 beta minus particles emitted and 1 alpha particle emitted to get the minimum possible. So 3 particles, a minimum of 3 particles have to be emitted to get an isotope of the original element back. That's logic. Either alpha beta minus beta minus, beta minus beta minus alpha particle, or beta minus alpha particle beta minus. Okay? Anything works. It will always match. 40. A nucleus of carbon 10 decays by beta emission to form a nucleus of boron 10. For this decay process, where is the change to a nucleon and where is the change in the quark composition of the nucleon? Okay, so carbon decays by beta emission to form this boron nucleus. So clearly it has to be beta plus decay and we will get an electron neutrino. So what has happened? Mass number has remained the same, but proton number decreased by 1. So a proton was converted to a neutron. So up, up, down was converted to up, down, down. Or more specifically, one up quark was converted to one down quark. So up becomes a down quark. And the conversion is from proton to neutron. So 40 is B. Okay. So hopefully guys, I was able to give you a concise explanation for all the questions. If I made any mistakes, please feel free to, point that out in the comments. I'll fix it then. And if you have other requests, please feel free to comment below. I'll try to solve those as soon as possible. I'll try to be more active from this year, and remember to subscribe to the channel. It really helps a lot. And consider supporting me on Patreon as well. You get access to all these solved question papers and notes. So I'll actually give a link for the Feb March 2023 paper 1-2 up here, and the link for May June 2023 paper 1-2 down here, and the playlist for physics paper 1 up here. And remember to hit the subscribe button. See you guys. Bye bye.